Hi, in this short session, I'm going to explain about high-level languages like Java and low-level languages like assembly language, for example. So at the moment, if you look at the screen, you will see that I am sharing with you how the RAM internally are organized. So if we have a look at the left side here, so the RAM, every area in the RAM have an address. So we see the addresses are actually listed in binary, okay? And on the right-hand side here, we see the data, and they are also written in binary, okay? So we have here addresses, and we have here data. So the data can be anything. It can be your video that you are playing, or can be your sound, or can be your document that you are editing at the moment, or can be a program that we have written and we want it to be executed. So we will see now a simple comparison between an addition that it can be written in Java and an addition that can be done using an assembly language. Okay, so this shows a microprocessor and the CPU and the internal structure of the CPU itself and how it accesses instructions that is saved in the memory. So this data can be instructions or can be real data like integer 5, 10, 100, or 1,000, or even a double, which means that it's a decimal number, or it can be a string like a text, for example. So we will go through that a little by little in our programming classes. But at the moment, what I want to share with you, we want to focus here about the difference between something that can be done easily in a high-level language like Java. For example, we are adding here two numbers, 5 and 2. And after we are adding them, so these 5 and 2, after we add them, it results in 7. And then we take whatever on the right-hand side and we assign it and save it in a variable, a place in the memory that can take an area of an integer in the RAM. So in the RAM, inside the RAM that we shared with you in the previous slide, so by the end of executing this line of code, which is Java code, we will save in the RAM a place called sum, which internally carry an address. We do need to memorize that address because we are dealing with high-level language. Inside it, we will find 7 stored, okay? So this is a process of adding two numbers. Now, let us have a look at the same exact code. If we write in a language like assembly language here. So load A, okay? So we have 3 instructions to do this summing operation, okay? We will go into it a little bit without going into too much details. So load A means, it doesn't mean that A, 8 here, load A, 8, it doesn't mean that 8 here is actually a number that we need to do an operation on. 8 here is an address in the memory. So inside the memory, if we go up here and try to simulate that, so we are on the same page. So 8, we have also address 9, and we also have address 11. Okay, so the point here that when we say load 8, so the CPU go to the RAM, and then he takes the contents at the address 8, which is in this case would be 5. So 5 is an integer, a normal integer, which is similar to the number here we saw, and it is saved at the address 8. Okay, and then we say add 9. So add 9, it's a assembly language instruction let's say, to the CPU, go to the place, to the address 9 in the RAM, and get its content, which is 2, similar to here, okay? And then load it into the CPU and add it to the previous numbers that you got from the last operation. So this kind of operation is actually done in the CPU registers. So at the start, LDA 8, it will fetch the content of address 8 from the RAM. It will put it in a register in a small place in the CPU microprocessor, the chip itself. Okay, so we will have here 5. And we go to add 9, we will fetch whatever data we find at address 9 in the RAM, and we will fetch that and we will store it in the microprocessor in another register called 2. And then since the add 8 is an instruction that say whatever you get from 9, add it to the whatever you fetch it from the previous instruction, which is stored in a place in a register in the CPU or a place in the CPU to hold this kind of arithmetic operation. So we add both, and then we store the result also in the microprocessor. So instead of having 5 here, we put 7, the result of the arithmetic operation, adding these two numbers, same like here. Okay, so what will happen on the next instruction? STA 10 is saying that get the result of the arithmetic operation that you already performed, and it is stored in a place in the microprocessor, and save it in the address 10 in the RAM. So now we need to put it in the address 10 in the RAM. So the point here is that we go into too much details. When you're writing an assembly language, you go to too much details. And then you also have to care and worry about the addresses of the RAM. So it means that you have to really remember what data you put and where you put it. And you have to remember that. You have to also try to remember this instruction do what kind of arithmetic operation and for what reason. So here we do the sum. So imagine that you are writing a long code that is maybe 100 or 200 lines of code of assembly. That's too difficult. It is very hard to remember the addresses. Okay, and before the assembly languages, when the computer come out, people have to deal with machine code. So machine code is actually more tedious and hard to understand. So this is still a little bit understandable compared to this. So this is the totally binary representation of this this whole instruction. Okay, so this is machine code. So what happened here, that this assembly language actually is also not understood by the microprocessor. It needs to be translated to the machine code at the end, because the computer and the microprocessor inside only understand binary. So everything that we write, okay, either Java or assembly language, all need to be converted to machine code. But again, when they created a high-level language for us, they make our life easier. So that's why we should be happy learning a high-level language like Java and Python and Visual Sharp, C Sharp, and Visual Basic, and so on. Okay, I wish you like my explanation, and see you next session. Bye-bye.